All right, let's continue factoring binomials. So a binomial is polynomial with two terms. So observe the geometric patterns below because this is going to help you to do some specific binomial factorings. So if you look at a squared, we can imagine that as being a by a square, right? A here and a here. That's just like our algebra types. What if I say minus b squared? How can you imagine that? That means I'm taking out another square out of this big one. I'll assume a and b are large enough to do that. So I'm taking away a b squared out. So this is b and this is b, and I'm taking a b squared out of a squared. So here's a squared, and I'm taking away b squared. The question is, how can I make this leftover part here look like a rectangle? What can I do? I can split it. So this already is a rectangle. What can I do with this piece? So I'm going to have to play with these two pieces and see if I can move this somewhere interesting. So let's move it. From here to here, it's A. From here to here, it's A. But from here to here, it's B. So from here to here was B. So this part from here to here is going to be A minus B. From here to here was A, and I took away this B part. So this part is also A minus B, which suggests that I can take that piece and rotate it like that, and then it should fit right there. Then from here to here was my A, which you see here. This part here was B, so when you rotate it, that went there. And from here to here was A minus B. That's why it fits there. And so what's the area of this rectangle then? This is A plus B times A minus B. So that's how difference of squares factors then. Difference of squares, the factors are A plus B times A minus B. Isn't that interesting to see this geometrically? All right, let's do some examples using that formula then. So let's factor difference of squares. Again, remember our goal. The first step in any factoring is to pull out greatest common factor and then use other techniques. So let's try that. So x squared minus y squared is going to factor as x minus y, x plus y. What we're really doing is just substituting a to be x and b to be y. Can you see how substitution works? That's how all of them are going to work. All right, let's try that. So the first task is to get this difference of squares to look like this. The only way you can do that is if you wrote it like that. Make it look like something squared minus something squared. Go ahead and do that. And then if you do that, then the factors are going to be whatever goes in the bracket here, that minus whatever goes here, and then that plus that. So let's see. Whose square is going to give you 25? That would be 5. Whose square is going to give you x squared? That will be x. So what goes in here then? That's 5x. So if 5x goes there, then this is going to be 5x and this is going to be 5x. So let's just fill those in. What's going to go in here? 16. Whose square is 16? That will be 4, right? So 4y goes there because y squared is going to be gotten by giving y here, and then when you square it. So 4 squared is 16, y squared is y squared. And so 4y will go in the second spot here. Can you see? So the A is now 5x and the B is now 4y. So it's a substitution, really. So go ahead and do the next one on your own. Pause the video and try. So again, get it in that form. So this is fixed. If you have difference of squares, it's going to look like this. Now all you have to do is figure out what goes in here, and then fill the rest. Pause the video. Go ahead, try it. So whose square is 49? So good, 7u. So that will go there and there. 121, so that will be square root of 121, which you know how to do. Factor 121 and take square root. 11v, good, and then that will go here and here. All right, try next one on your own. Hey, next one, look. I can't really use difference of squares here because 8 is not a perfect square, is it? So first, remember what our first step is. Look across and see if there's a greatest common factor to pull out. And is there? Do you see a greatest common factor between 8 and 18? Try it. So 2. 2 is factoring. Good. When you factor the 2 out, you're going to have 2 times 4 is 8. 2 times 9 is 18. So that works out. Now this is the difference of squares. So the 2 is just going to follow through. So 4a squared, so that's going to be a 2a and a 3b, and then complete it. So what goes in the first bracket there? Good. 2a goes there. 3b goes there. So 2a minus 3b and 2a plus 3b. Would it matter whether I write 2a plus 3b times 2a minus 3b? Does it matter which term I write first? The answer is no, because of commutative property of multiplication, right? All right, try that. Again, factor out the greatest common factor first. So they share a 5, they share a s, and they share a t. And now we have difference of squares, and go ahead and factor them. So now you just have to write these terms here. Good. Any questions here? Please rewind and rewatch it. This is very important. If you're not getting it, pause the video, rewind, and keep trying. Don't give up. This is sometimes where people fall apart, because for some people this can be very difficult. And if you are one such person, there is no harm in rewatching and trying to understand. Otherwise, do talk to somebody in person, because that might help you immensely, because they can see where you're getting stuck. All right, how about that? I can pull out a 3. Now, this is an addition of squares, and 7 is not even a square. So does it factor anymore? No, good. So this is it. All right, how about that? That is a difference of squares. So can you try? Whose square? Something square is going to give me x to the 4. What is that something? It's going to be x squared. So x squared here, and here. Y squared will go there, and there, and there. Are we done? Hey, remember what it says? Factor completely. So if completely, I have factored here, but not completely, because look, x squared minus y squared factors again. So now what? So the x squared plus y squared factor is going to stay as is. So that we cannot change, because that does not factor anymore. But x squared minus y squared factor, so what do you think you should put here? X. So that means we can put x here and here. What goes here? Complete it. Good. So those are your factors. This factor, remember, it carries through. You can't just leave off some factors. Try these on your own.